Hello. Today we will be presenting our final project for the Statistical Control for Quality course.
This project will propose a solution for an industrial engineering problem by means of statistical tools. The method chosen for analysis of this project is the NP chart. We will put into practice the theoretical concepts seen in the course by giving them a formal application to take advantage of the knowledge acquired. At the same time, we will gain practice experience for real-world problems.
Problem statement. Poralfare is a Mexican company dedicated to the manufacture of construction bricks. The company has received several complaints from customers from an unusual number of defective bricks in the batches sold. Management has decided to carry out a quality control inspection of 40 samples from different batches. Each of the 40 samples contain 50 bricks. Data on the effective and non-defective bricks will be obtained. 20 samples will be obtained from the morning shift and the other 20 for the afternoon shift.
The main issue to be solved in this industrial engineering problem is to analyze the reason for having batches with a higher proportion of defective bricks than the allowed. We will use an NP chart to understand the behavior of the production process and then find the origin of this problem and solve it. Two graphs will be made to contrast the performance of the process in both shifts, and it will serve to detect anomalies in the current situation. The methodology and steps to be followed in the project are presented below, as they were previously explained. According to the literature, the calculations should be performed as it follows. When performing the relevant calculations for the construction of the NP graph, we found the results shown on the screen. As can be seen in the NP chart for the morning shift, the manufacturing process is in statistical control. It presents common sources of variability, which are interpreted as noise. For this reason, a further analysis of this shift is ruled out for the time being. However, when looking at the behavior of the process during the afternoon shift, we observe that there are three signals, all of them indicating causes of variability external to the process, in addition to showing intermittency in the process and evidence of lack of control. We realize that the reason for the problem with the proportion of defective bricks may have its origin in the afternoon shift.
On this part, we saw that the main reason for brick defect were because it had cracks or was chipped. We can observe a process with a center line of 2.85 effects per lot for morning shift. In general, the process is under statistical control and with common sources of variability. On the other hand, on afternoon shift, we have a higher central limit of 3.25, while in the NP graph, we had 3 alerts that exceed the upper central limit. The company must make emphasis to improve the production process for the afternoon shift in such a way that the number of defective bricks is improved and thus eliminate the alerts from the NP graph.
To conclude, we can say that when calculating the defective items with the NP chart, we obtain the highest number of defective bricks in the afternoon shift. For these reasons, the company should propose as a solution to give advice to employees and put managers to inspect each area of production. Regarding the machines, they have probably been working for 16 continuous hours at the end of the shift, causing them to become out of calibration. It will be good to do predictive maintenance to avoid this situation. With these solutions, it is expected to reduce the variability in the process, keeping the product within the control limits. My contribution to the project was to reach a conclusion by proposing possible solutions to the company's problem.
My contribution to the project was help to choose a situation in which we could apply statistical tools controls and the analysis of the results.
My contribution to the project was to perform the necessary calculations to construct the NP charts. Thank you.